I'll do a tutorial one to warm up because this isn't a well-known thing, so I'll just kind of do one just casually as like a warm-up one. Just kind of like I'm just making stuff up in terms of warm-up, but I'll do one anyway, just to let chat know what's going on. So I'll explain this once again. I do one of these every day just to explain. Basically, the goal of Ken's or Math Sudoku is to be able to finish the puzzle with every given math and operation, while also keeping Sudoku rules applied to this as well. Basically, that's just a general way to describe it. I'll go into more detail. For example, this one is a given, and this 5 is also given 7. So let's start with this 8 minus. So this is what I want to do. So you want two numbers when subtracted together gives you a difference of 8. So this is the number you're looking to solve for, is what you want your to equal, and this is the operation that you're using. So with Sudoku, with a 9 by 9 part, you're only given 1 through 9. So the only combination that works to give you two numbers subtracted together to give you a difference of 8 is 9 and 1. These are notes to signify where your numbers will up. Now, I don't know what order it's going to be. This could be a 1 first and a 9. It doesn't matter like what order it is. It's not going to be specifically 9 minus 1 like this. It could be, but not necessarily. Basically, it's just always implied that a larger number minus a smaller number just to keep things simple. So with this column, let's look at this 30 times as well. So you want 3 numbers multiplied together to get you to 30. Now, there's two combinations that work with this. No matter what, you have to use 5, and it's 5 times 2 factors that will get you to 30. Basically, it's combinations of 5, 6, 1, 5, 3, 2. Now, this is where the Sudoku rules come into effect. I mentioned this earlier. I actually don't know if I mentioned this in today's stream, but you can't have 2 repeating numbers in the same column or the same row. You know that one has to be using this 8 minus in this column and has to be right in here. So that means the 1 is already taken out. So this means that 30 times cannot be 5, 6, 1 because this 8 minus has to use a 1 in here. So it has to be 5, 3, 2 in some order. So as you saw here, I can also drag my nodes to basically duplicate them into this segment here. That's kind of save time. We have another 8 minus here that's still 9 and 1 only. Here's another one here, and since this 1 is taken out, this 8 minus, this has to be 9, and this has to be a 1. So 28 times, there's only 2 numbers within here multiplied together to get you to 28, and that's 7 and 4. And of course, 7 is taken out of this square, so this has to be a 7, this has to be a 4. 24 plus with 3 numbers is always going to be 9, 8, and 7. They're just the 3 largest numbers, and you just have to add them together. It's the only combination that works just horizontally, or not horizontally, vertically like this. 72 times with 2 numbers is always just going to be 9 and 8. Ooh, I haven't had this opportunity to explain in chat this yet, but there has to be a 9 or an 8 in one of these 2 spots. And you know it has to be a 1 and 9 in these 2 spots. The point of this is you have to have a 9 here or here, or you have a 9 and you have a 9 here or here. These are the only 2 spots in this row where a 9 can go. If this is a 9, this has to be an 8. If this is a 9, this has to be an 8 here. No matter what, if this is the 1, this would have to be a 9, which would force this to be an 8 and force this to be a 9. Basically what I'm saying is the only places 9s can go into these 2 rows would be here or here. Or it can go here and here. In other words, these 2 9s cannot work no matter what. I'll show you why. I guess I can't explain that poorly. Say if I made this a 9. This would be an 8 and this would be a 1. What will it be below this? If I make this 8 and 1, you have 9 and 9, and you can't have 2 9s in the same row. That's what that means. So you can't put in 9s here and here because they're forced to go into these 2 spots, and one of these 2 spots and one of these 2 spots. So this has to be a 9. Oops. Sorry, I'm just used to opening tabs. I'm not used to like switching want to seeing if chat's understanding where I'm going with this. Okay. So yeah, that's a neat trick to figure out certain numbers, where they can and can't go. Since I know there has to be nines in one of these two spots and one of these two spots, there can't be a 9 in here. Okay. 576 multiplied together with 4 different numbers, shape of a Tetris piece. So what I know here is that this is divisible by 9. Simple math trick to figure out factors of large numbers like this. If the sum of the digits add up to a number that is divisible by 9, then the number itself is divisible by 9. In other words, 5 plus 7 is 12, plus 6 is 18. 18 divided by 9 is 2. Since 18 is divisible by 9, this number itself is divisible by 9. So in that case, a 9 would have to go here, assuming there is a 9 in this problem. The problem with numbers that move into multiple rows and multiple columns is you can have two of the same number in this equation. So 576 is 9 and 64. I know that much. So in theory, assuming the 8 minus didn't exist here, I could very well have like 8, 8, 9, 1. I could have two 8s here or here. They're not in the same row or the same column, so that could work, assuming that this didn't exist. It's not the case, obviously, because both 9 and 1 are taken out here, so you really have to have two 8s here for that to work. And obviously, you can't have two 8s in the same column like this. So what I'm trying to figure out is if I can get to 576 with 4 numbers without using a 9. Otherwise, I can make this a 9. So I know it's 964. It's 8 and I believe it's 72. It's 8 and 72. Let me think for a second. 8 and 72. Add that to 144. Yeah, it's 8 and 72. So I could do like 8. I can't do 8833. I could do 8643. Yeah, because it's 8 and 72, 6 and 12, 4 and 3, or 8 double 6 2. Okay, so yeah, so this is not necessarily a 9. So I can make this a 9 still. I can make this an 8, 6, 4, 3, 2. These are all my notes I could use here. I'm going to drag to all these slots and remove the 9 in this. Okay. There are so many 8 minuses. This is also 9 and 1. So yeah, if there is a 9 in this 576, it's here. Otherwise, it's 8 and 72, 6 and 12, and you can do 6, 2, or 4, 3. Or something to that effect, at least. I don't exactly know, and I don't necessarily need to know either. Maybe it could get to a point where I could solve enough of this puzzle where the numbers just work out anyway. Okay, 360. This is always 5, 8, and 9. It's 5 times 72. That just gives you 360. 6 times is either 1 times 6 or 2 times 3. I've clicked so many times there. Okay. Stream's not really lagging that much for me. That's good. 288, that is 9 and 32. So this can be 984, and this would have to be a 4, or it's 8 and 2 6s. Basically, it's 8 times 36, which could be 8 times 9 times 4, or 8 times 6 times 6. Oh, and this can't be 6. This could be a 4. Okay. What does that mean for me? That's fine. Okay, we're fine where it is. This can't be a 9 here. Okay. I'm trying to see if there's any stuff that's basically given to me. Okay, let's look at this 3 divided by. So there are 3 different combinations that can go into 3 divided by. Either 3 divided by 1, 3 divided by 9, or 6 divided by 2. 9 is fully taken out here, so it's either 3 divided by 1 or 6 divided by 2. Like I said earlier, it doesn't matter what order it goes into, but Um, this is 1, this is 3, it's just a large number divided by a smaller number to give you the quotient. And with that, this is also 1, 2, 3, or 6. And what's nice about this is that we have 4 different numbers in this row that is either 1, 2, 3, or 6. So I have to use all of them within these 4 spots, which means this is our 5. So we have 1, 2, 3, 6, 5, and 9. That leaves 4, 7, and 8 remaining in this row. So this is 4 or 8. And below that, this is 4 or 8 or 2, because I can do 4 divided by 2, 8 divided by 4, or 8 divided by 4 this way to get to 2. This will be 4, 7, or 8. And same with this, without the 8, I guess, because of the 72 times. I could try to figure this out, but there's too many combinations with 2 different set of numbers that will just leave me with a lot of notes, so I'm not going to bother trying to deal with this. So this, I can add a 9 to it, because I can still do 9 divided by 3 here. Okay. Let's see. This 7 plus, I know it can't be 4 plus 3. It's either 5 plus 2, and this would have to be a 5, and the right would have to be a 2, because there's 5 down here, or 6 and 1, and it can go either way, I think. Yeah. See how chat's doing? Okay, I'm doing alright. So, what do I know? Oh, this is what I know. So, this 2 divided by, so it can't have a 1 in it. And for this 2 divided by, it's either 8 divided by 4 or 4 divided by 2. Either way, this has to use a 4. So I can't use a 1 in this 2 divided by, I can't use a 4. The only 2 numbers that can work in this 2 divided by now is 6 divided by 3. I can't use a 2 or 8 because both the 1 and 4 are taken out here. And also I can't use an 8 because a 4 is taken out here. So, what's that leave me with? 1, 9, 4... Okay. So, sorry, I need to think for a second. Okay. So we're left with, in this column, numbers that are not in guaranteed spots. I know 4 is in one of these 2 spots. I know this to be 1 and 9. I know this to be 3 and 6. So I'm left with 2, 4, 5, and 7. With that in mind, this is either 2, 4, or it's 5, 7. Wait, no. Sorry. 2, 8, 5, 7. That's what I meant to say. So I know this to be 5, 7. Because there's only 2 numbers that can give you a difference of 2. Making this only 2 or 8. If this one were 8, that leaves with a 4, so it had to be 3 and 1, and both those are taken out here. So I know this to be the 2, and that's going to be 4 and 8 in some combination. So that leaves us with 10 here. Can't be 9 and 1. Can't be 8 and 2 because of this 2. Can't be 7 and 3 because of the 3's here. This would have to be 6 and 4 in some combination, and I don't know yet. That's okay. And there's 2 numbers I'm left with here, and it looks like it's 7 and 8. Okay. 1, 7, 8, 9 leaves me with 2, 3, 4, 5, 6. So this is 2 or 5 or 3 or 6. I'll put my notes on that. So I said 2 or 5 or 3 and 6. So it'd be 5 here, and it'd be 3, 2, 5 here like this. Okay. And this will be 2, 3, 4, 5, 6. Sorry, I'm just thinking for a second. Trying to see if there's any reason why this can't be 2 and 3. This is 2 and 3. This is, take out everything here. This would be 6 and 1. That's a 9. That could still work. Okay. Now I'll just put it in. Why not? I'll just throw them all in. 4 goes away there, but nothing goes away at the bottom. I just have to add a 4. Okay. So yeah, I am prone to definitely making mistakes with these as well. So, like, I'm not perfect by any means. So I could definitely make a mistake in a tutorial as well. Like, I could definitely glance over something. Let's see. 13 plus here. 9 has to go in this column somewhere because the 9 can't go here anymore because of this. Point is, 9 is in here and 9 is in here, so this can't be 9 plus 4. So it's either 8 plus 5 or 7 plus 6, and I don't quite know yet. 8, 5, 7, 6. So that can't be a 7 there, so it can't be a 6 over here. So look like that. And there's another one here, and it's the same thing. It's 5, 6, 7, 8. Wait, yeah. What else do I know? Okay, I just saw this. Same thing what we did with the 9s over here. We have two sets of 8s. And this was actually early on. So we have two sets of 8s here that have to go like this or like this. So this is a 4 because it can't be an 8 there. And this is our 8. Which makes these both 4 and 7. I guess I still knew that. I guess this is now just 4, 7. There's no longer an 8 in here. 4 leaves us with 12. I'm not going to think about that. What else do I know? This is no longer an 8, which means the bottom is no longer 5 because 5 plus 8 gives us 13. Since there's no 8, this can't be a 5. This could still be 6, 6, 8. Could still be 9, 8, 4. Okay, yep, that's fine. Oh, actually, it's no longer 8, 6, 6. I'll show you why. One of these two, so this is 4 or 6 guaranteed, which means one of these two has to be a 6, meaning that these can't both be 6s if one of these is a 6. So the 6s go away here. So since this 6 goes away here, this 8 and 9, this is 9. That's a 4. And this will be just 8 and 9 here. Which makes this a 6 and this a 4. So that leaves us 7 here. So the 7 goes right here because there's no 6 on this side now. Okay. 1, 4, 7, 9 leaves us with 2, 3, 5, 6, 8. All of those numbers could still work. I guess not the 8s. So I guess it could still be 2, 3, 5, 6. Either 5 minus 2 or 6 minus 3, like this. Yes, okay. This 4 minus is not 9 and 5. It's not 8 and 4. It's not 7, 3. It's either 6, 2 or 5, 1. I'm going to leave this for now because I know this to be 3 and 2. For sure. The reason why is that a 3 cannot go anywhere else in this column whatsoever. Because this, in order for this to have a 3, it would need to be 7 minus 3, and of course there's a 7 here, and we have no more 3s labeled within our notes. So that's why this has to be 3 minus 2, because the 4 is taken out up here. So to go back to this can no longer be 2 and 6, so this has to be 5 and 1. Since the 1 and 2 are taken out in this column, this forces this to be 6 and a right to be a 2. So that leaves us 1 and 3 here, so this is only 2 or 6, because it's 1 times 6 or 3 times 2. And then since the 2 is taken out here, the 5 goes away, so this has to be 3 and 6. Which makes this be 5 or 8, which makes the right side only 5 or 8. What else do I know? 5, 8, 9, 5, 8, 9, 5, 8, 9. So we have to use all 3 of these numbers somewhere within this column. So this makes this has to be a 7 and this be a 6. Which makes this be a 2 and this be a 3. See this being a 3. See this being a 6. This is 4 and 1 in some combination. This is an open 5, open 7. This is now a 9 because the 8 has to go in one of these 2 spots, and this is an 8 here. This is an 8. This is 7. This is a 1. This is 3, and so on. Another tool here. Press the check mark to see what notes you're left with. So there's only a 5 left in this column. This can only be a 2 or 8, so I know this to be a 2. This is a 4. This is going to be a 2 or an 8, so 2. Excuse me. Yeah. So that'd be a 3. So what the check mark does, I'll explain more about it. It shows you what notes you have that aren't eliminated by fully given answers. If I put check mark here, actually, let's see if one of these goes. Okay, yeah, this is a good one. So these can't be 1, 2, 3, 4, or 9 because obviously they're already used in these spots here, of course. So that leaves us 5, 6, 7, 8. However, they still remain even though you have notes that confirm this having to be guaranteed to be 5 and 8 here. It still shows up here though because it's not like given as a confirmed answer yet. We don't know which one of these is 5 or 8 yet. So like in theory, the system still believes it still gives you the possibility of this being a 5 or 8. We know this it has to be in here. Basically, if there's a confirmed answer in one of the slots here, it can't be used if it's bolded like that. But yeah, so this has to be 5 and 8 in some order. This is 6 and 7 in some order. So this has to be a 3, of course, and this would be a 6. It might just unravel at this point now. This might just be solved. I could try to like whittle this down and figure it out. Actually, I will. Because I know this to be 8 and 72, and it's 4 and 18, so I need 9. Okay, so I know that much. Sometimes you don't really need to like know the exact numbers to multiply together to get to that. But since I know this has to use both 4 and 8 here, I just did it anyway, just because it's just easier for me to just it wasn't that difficult to figure out. So what makes the most difficult part about this, I mentioned this earlier in different streams, although people probably weren't around to hear it. The multiplication stuff is not the most difficult thing. The toughest things about Kenkens is stuff like a 14 plus. An addition problem that is in a shape like this. Because any sets of numbers can be added together to give you 14. I can use any number and I can use numbers as well. So like that's what makes things the most difficult with Kenkens are addition problems, not even multiplication. There is some stuff of multiplication that makes things difficult, but really the giant numbers, like this isn't even that large even. Like I've seen plenty of 4-digit numbers with multiplication, but if you know how to if you can divide well in head and like find simplified factors and stuff like that, multiplying can give you some confirmed numbers, another like combination of numbers that could work. But usually when you get a multiplication problem, there's usually a prime number or like there's a number that you know has to be used no matter what, even though you don't know all the actual factors being used yet. This is a 6. But yeah. At this point, this puzzle is just solved. I'm just kind of filling notes at this point, and this will be 2, 4 plus 2 is 6, plus 8 is 14. There you go. There's just an explain Kenken. I put the wrong thing, didn't I? That's okay. So yeah, so see how the stream's doing. Oops. There we go. But yeah, that's just a simple Kenken. But yeah, that's just going at a casual pace just to explain just how these work once again. So yeah.